Hey there everyone, it's Mr. Sheenline. This is going to be the video lecture for the Unit 3.4 Part 1 notes. If my memory, yes, so this would have been, this is more of a video for if you were absent on the day that we went through this in class, because we would have gone through this in class, or we did go through this in class, sorry. This is going to be the notes over acid and hydrate formula creation. So we're first going to, this is going to be the notes covering how to make the formulas. The part 2 notes are going to be how to name them using formulas. So easy enough? Let's get into it. So first we got to figure out what's an acid and what's a hydrate. So simply put, an acid, and you need to know these definitions by the way, an acid is any substance that gives off a hydronium ion, positively, arguably speaking, it's not technically a hydronium, I shouldn't say that, but it's a hydrogen cation, okay, when dissolved in water, okay. Hydrate is any solid ionic substance that has water locked into its bond. So anytime that, like it says, anytime you have an ionically bonded material that just has water in it, it's a hydrate, okay. So, and that'll be quite obvious when you see them, and quite obvious when we see their names, okay, because hydrate's literally in the name, okay. But first, let's focus in the acid formulas. So when we're making acid formulas, we have to first identify the substance as an acid, okay. Easy enough. The name of it ends with acid, okay, 100%. You see acid at the end of it, it's an acid. Okay, so that's step number 1. Step number 2, every single acid has a positively charged hydrogen cation as their cation. Okay, every single one. I cannot stress that enough. If you see an H in the beginning of a compound, it's an acid, okay? Now, that's going to be more pertinent when we get into naming, or when we get into the naming, because in the naming it arguably is a little bit more challenging. So, okay. So every single cation is going to be the hydrogen cation, positively charged hydrogen ion, and then after that we've got to determine the anion. So if the name has the prefix hydro, then the anion is monatomic. I'll read that again. If the name has the prefix hydro, then the anion is monatomic. Look up the anion up on the periodic table, periodic table or your list to find the charge. Now, if it does not, sorry. If the name does not have the prefix hydro, then your anion is polyatomic. Okay, so what you'll do is you'll find the polyatomic that ends with ATE. We will not be working with ITE polyatomics, only ATE polyatomics with the same element name from the acid using your polyatomic anion sheet. So use your anion sheet here. The one with the big old list on it, look for the ATEs, ATEs, your sulfates, your phosphates, your nitrates, not we're not looking at the nitrites, the phosphites, the sulfites, no, ATEs only. And then simply we're just going to create the formula the same way you would create ionic formulas, okay? So use the charges and crisscross method to make the formula. Oh my goodness, I am so sorry. Okay, so again, let's look at these 2 examples here. So I'm going to walk you through the steps 1 through 4. So number 1, identify the substance as an acid. Boom, both acids, cool. Moving on, number 2, all acids have H plus as their cation. So I'm going to do that. So all of them, they've got them looking like this. Okay. Now, got to determine the anion. So my anion, sulfuric. So I've got hydrosulfuric and sulfuric. So hydrosulfuric, sulfuric. So let's focus on just this one up here. So if the name has the prefix hydro, okay, then the anion is monatomic. Perfect. So here, since it has hydro, I've got the prefix hydro. That means it's just sulfur. Okay? So I'm going to write S. It's just sulfur. And I'm going to either look on my periodic table or I'm going to look at my monatomic list and see what its charge is. So I'm going to look at the periodic table. It's under oxygen, so that means then it's going to be a negative or 2 negative. Okay. What do you think we got to do now? Crisscross, silly willy. And what we're left with is H2S. Okay. Easy peasy. Now, sulfuric acid. So this guy does not have the prefix hydro. And remember, we only use the polyatomics that have the ending ATE. So I'm going to look on my list. Okay. Let me grab my handy dandy list here. So sulfuric acid. So what I know is it's sulfur. Okay. I know sulfuric. I mean, come on. Sulfuric sounds like sulfur. So I'm going to look here. I'm going to look for my S's. I don't see any S's over here. Aha! Ooh, look at that sulfate right there. So I'm going to then plot down SO4 to negative. And the same thing, my dudes. Crisscross. If you get it wrong, no applesauce, my dude. H2SO4. It's that easy. Okay, so let's take a look at these. I'm going to do 2 of them. I want you then to do the 3. After I've walked through the first 2, I want you to then do the 3 on your own so you kind of get a sense of what's going on here. Okay, so let's take a peek here. So hydrochloric acid. Okay, so, and by the way, I mean, just look at each of these, of course, because we're talking about acids here. Each of them is going to be an acid. The name acid is at the end. But let's look at this guy right here. So it looks like I do have a hydro here. So the first thing I'm going to do, hydrogen ion, always. And I'm even going to put it down here in this one. Okay. Hydrogen ion, chloric. Well, what does chloric sound like? Well, chloric, that sounds to me like chlorine. So I'm going to write down chlorine. I'm going to look up to see what chlorine is, and it looks like it's a 1 negative. I'm going to crisscross my guys here, and what I'm left with is HCl, hydrochloric acid. Okay, so let's take a look here at number 2 then. So again, I've got my first step here. I'm going to, second step, because I've already identified it as an acid. Look, there is no prefix. All I've got here is this nitric. Okay, so let's then ask the question. Well, that must mean then it's before we ask this question, if we see it's nitric, and specifically we don't have hydro in the beginning, that must mean then it's a polyatomic ion. So if it's a polyatomic ion, which one is it? Well, if it sounds like nitric, I would imagine it's probably going to be nitrate. So let's take a look here and let's find nitrate. Okay, boom, there's nitrate right there. NO3, 1 negative. I'm going to circle them, crisscross, and what I'm left with is HNO3. Easy enough. Okay, so I want you to go through the last 3 here on your own. Try them out for yourself. So pause the video here, try them out yourself. Once you're done with them, hit that play button again, and then see if you got them right. Okay. So let's keep on going. So carbonic acid, and so, okay, we can look at these. We know all 3 of these are going to be acids. So I'm going to just get rid of the first and second steps. Just get them out of the way. Get them out of here. So carbonic acid. Well, what does carbonic acid sound like? I don't know. So let's maybe look at the options that I have on my list. So I'm going to look for like something that says carbon on it, carbonic or carbonate, whatever it may be. So chlorine, okay. Well, it kind of sounds like carbonate. And not only that, carbonate does have the ATE ending to it, so I'm pretty sure that's what it's going to be. And that is going to be CO3 2 negative. And sure enough, this is the answer here. So yippee, hoo-hoo. I'm going to crisscross, and what I'm left with here is H2CO3. And I have my answer. Let's go down here, hydronitric acid. Now, we've already done nitric acid, so if there's a hydro in front of it, chances are it's just going to be nitrogen. So we've got 1 plus for the hydrogen. Nitrogen is going to have a 3 negative because it wants to take in 3 of those bad boys. Okay, 3 of those electrons. Going to simply crisscross. What we've got is H3N. We have our answer here. Acetic acid. Again, you've got to ask yourself, what does acetic sound like? Let's check out our list. Well, here's acetate. It has the ATE ending, but just to double check, I'm going to just quickly kind of look through here. Oh, no, A's. Nothing really. No, these don't sound right. Yeah, because it's acetic. It looks like, for the most part, acetate is the closest thing here, so which would be correct. So C2H3O2 1 negative. Crisscross. What we're left with is HC2H3O2. And we have our answer. Easy peasy. Let's take a look now onto the back. So hydrate formulas. So for the most part, this is going to be quite similar in how we identify all these bad boys. So, or at least how we identify and what we do with them. It's just hydrate has an extra step to it. So we're going to identify the substance as a hydrate. And we know it's a hydrate because it has the name hydrate at the end of it. Okay, so acids have monatomic acids with monatomic ions have hydro as a prefix. Hydrates will have hydrate at the end of its name, or I guess, sorry, that's the wrong comparison. Wrong comparison here. Acids will have acid at the end of its name. Hydrates will have hydrate at the end of its name, so it's similar in that kind of sense. So we're going to create, after we've identified which one's a hydrate, we're then going to create the first part of the formula using the ionic formula creation method. So charges, we're going to use the charges and crisscrosses. Okay, so there's 2 parts here, and this will make sense when I'll show you this example. There are 2 parts. So the first part, again, is going to be, it's going to look just like any other ionically bonded compound. The second part is going to be separated with a dot, like a multiplication dot, and that's what's going to be that hydrate part. Okay. So we're going to think of those prefixes again. Those mono, di, octo, hecta, hexa, penta, all those good guys. Nona and deca. Identify the number that goes with the prefix belonging to the hydrate and put that in as a coefficient. So the word coefficient here, think back to your math. This is going to be a big number, not a small number. It's not an exponent. It's not a subscript. It's not a superscript. This is going to be a big boy number going in front of H2O, which is going to be, that's the next part here. So add H2O after the coefficient. Okay, so let's see what that looks like. Let's just kind of do that all together. So we're given here calcium nitride tetrahydrate. So a whole bunch in here. So first I want to focus in on this half, and I'm going to separate both of them here. I want to separate because I see hydrate here, and I'm going to keep these separate because I want to figure this out first before I figure this out. So let's look here, calcium nitride. So calcium nitride. So calcium, Ca, nitride, nitrogen. Calcium is going to have a charge of 2 plus. Nitrogen is going to have a charge of 3 negative. Crisscross these 2 guys, and we're going to have Ca3N2. Okay, now I want to focus in on the tetrahydrate. So tetra, I'm going to separate all this with that multiplication dot. tetra, meaning 4, and then hydrate, H2O. That's it. It's as simple as that. And then this is our full answer here. So again, this is the first part. That's what I'm referring to, the calcium nitride, and for this guy down here, aluminum hydroxide. This is our first portion, right here. And then our dot, and then the incorporated water, so tetrahydrate. Tetra meaning 4, hydrate meaning water, H2O. It's that simple. So let's look at the next one, aluminum hydroxide. So aluminum is 3+, and I already know that. Hydroxide, that doesn't sound like that's a monatomic, so I'm going to take a look to see what my polyatomic is going to tell me. And it looks here, hydroxide is going to be OH1 negative. Okay. Crisscross, like usual. And then I've got AlOH3. Okay. Separate it with the little dot. Now let's take a look here. Heptahydrate. Okay, so I know that there's going to be H2O over here because it's a hydrate. Hepta. What is hepta? Well, let's go through mono, di, tri, tetra. It's definitely not tetra. Tetra, hepta, hepta. Oh my goodness, I'm losing my mind here. Sorry. Penta, then hexa, then hepta. Sorry. Hepta is going to be 7. And then we have aluminum hydroxide heptahydrate. It's that simple. So here, I'm going to do the first two, and then you are going to do the next two. So I'll walk you through these two. After I walk through these two, pause the video, do these two on your own, play the video again to see if you get the same thing. So let's kind of go through this. So potassium, and I'm going to do this again. I'm going to separate these guys. And, obviously see that, yes, of course, they are hydrates. So I'm going to separate them. I'm going to focus in on this side. So potassium oxide. So potassium is going to have a charge of 1+. Oxygen has a charge of 2-. I'm going to crisscross here. And I've got K2O. Then I'm going to worry about my hydrate. So trihydrate. Hydrate. So 3H2O. And I have my answer. Okay. Let's take a look at iron 3 sulfate, pentahydrate. So iron 3, so that'll be Fe3+. Okay. Sulfate, which is SO4, and I know that because it's a polyatomic, and I'm going to look on my polyatomic list. It's SO4 to negative. So it's going to then crisscross, and then I'm left with Fe2, parentheses, SO4 3. The dot to separate, pentahydrate. Penta is 5, hydrate means water. And I have my answer. Okay, it's that simple. So pause the video, try these out yourself, play it after you've got them to see if you got them right. Okay, so beryllium selenide octahydrate. So, and for both of them, I'm going to separate them here, just so I can focus in on this side first. So beryllium selenide, so beryllium is Be. Beryllium has a charge of 2+. Selenide, that's selenium, so that's Se, and it has a charge of 2-. Crisscross, so that I have BeSe. And remember, they're both 2s, so they cancel each other. Well, they reduce down to 1 for both of them, so it's BeSe. Okay. The dot to separate, octa, so that's 8, H2O. Boom. And then lastly, zinc carbonate. So zinc is going to be Zn. Now zinc is going to be that weird guy because zinc is one of the he is the exception, even though it is technically part of the transition metal list. It only has one. It only forms one particular ion. My goodness. excuse me, and it's 2 plus. Carbonate, CO3 2 negative. Crisscross here, and we're left with ZnCO3, because again that reduces as well. The dot, we've got the hexa meaning 6, hydrate meaning H2O, and there you have it. And that's pretty much it, guys. So you have enough now to tackle that worksheet pretty easily now. So go ahead and go complete that worksheet. Refer back to the notes if you are having some issues with it. And if you have further any issues that the notes can't help you out with, make sure you get a hold of me. So nothing else, I'll see you all in the next one.